All right, quick break, but we're back. So this is the first part of page 24. These notes right here, naming compounds and naming ionic compounds. This is the last new information that will show up for the test, which will take place... Wait, no, C-Day? D-Day? On E-Day. I'm pretty sure it's E-Day. It's listed. I know it's listed on the assignment online. It should say test on pages 1 through 24. It should say the letter day. It should say the dates. My online presence is more organized than my physical presence. And right now that's kind of how it's going to stay. My physical presence is not super organized. You can see the nonsense that's happening behind me. So it hasn't been fixed for a lot. Don't worry about it. But this is the last new information. I will ask you to do some of the examples down here, and then on D-Day, right, we'll do some review. Just of like this stuff, of recent concepts, of kind of old concepts, just so that you can see. Please stop calling here. I'm so sorry. I have no control over phone calls. I would edit that out in post, but I am not a strong editor, so... I apologize for blowing out everybody's eardrums there. That's really loud for me, and I have headphones on. Now, naming compounds is something that we have to do because we kind of know how to identify compounds. We know how to, create compounds from ions. We know how to separate compounds into ions. But we need to know how to name them, all right? There are separate rules for naming ionic and molecular compounds. And we're going to focus only on the ionic. We're only going to have the ionic compound naming rules on the test, right? The other stuff, we'll worry about the other stuff later. I will continue on with the notes, but we're going to cut right here at page 24. In order to name ionic compounds, we have to look at them in terms of like the positive and negative ions. The positive ions have a name. They are called cations, right? It's a cation. I don't know what else to say. The negative ion, unfortunately, is not a dog ion. It's an anion. The way that I've always remembered it is that cat videos on the internet make you laugh, right? It's kind of positive. And then anion almost looks like onion. They make you cry. That's kind of negative. Someone earlier today said that the T in cation looks a little bit like a plus sign, so that's how you can remember cation as positive. Most of the time you'll just have to, if you need to recognize cation or anion, you mostly just need to remember like the cation, okay, so the positive one. But anyway. The cation is a metal or a poly. I'm just going to write poly. You can write poly as long as you know that poly means polyatomic ion. All right. And it will keep its name. Right, so whatever it is, sodium stays sodium. Ammonium stays ammonium. Sodium is a metal, ammonium is a poly. The anion, the negative one, it is always the nonmetal, again, or a poly. Now, if it's a nonmetal, you're going to change the ending to IDE. So chlorine will become chloride. So when we talk about NaCl, it's sodium chloride. Polyatomics will always stay the same. And to reinforce that, if a poly is in the compound, you never ever change the name. Whatever you see on table E, that's it. You call it that. That's what scientists have decided the name of it is, so we're sticking to it. All right. Sometimes, when we're looking at these metals and we're looking at these elements that make up an ionic compound, sometimes we see elements like iron or elements like copper, where in this top corner there's more than one possible charge. And when we have more than one possible charge, we need to be able to say, with absolute certainty, which version of the ion it is, because they act differently, at least a little bit. In order to do that, we need to do something special. All right, so if the ionic compound that we're trying to make a name for, has one of those metals with more than one possible charge, so for example, iron. Iron could be +2 or it could be +3. If that's the case, then what we'll do is we will assign... What is happening? A Roman numeral. Now, if you don't remember your Roman numerals, it's not that big of a deal. We have 1, 2, 3, 4, and 5. Let me make that 3 very clear. There we go. So that's 1, 2, 3, 4, 5. That's about as high as you'll ever go. Now, when this comes up, you need to figure out what is the charge on that metal. And that is why I did this first, so that you can identify what is the charge of the metal. Right? When you have to do these, right, they will end up looking something like this. Now, 1 and 2 and 5 are examples that I'd like you to try now. If you haven't already, if we're reviewing this from class, that's fine, but if you're doing this for the first time, pause the video, and I want you to try practice 1, 2, and 5 over here on page 24. Let me zoom in. 1, 2, and 5. Pause the video, give those a shot. Back. Okay, sorry. So the first part of number 1 is magnesium. If I look at magnesium on the periodic table, it has only 1 charge, so I do not need to worry about the Roman numeral. I do not need to worry about a parentheses. Right? What we do with that Roman numeral, by the way, we put it in parentheses after the metal. I'll show you an example of that in number 3, but I want to just go over these ones first. F is the element fluorine. When it becomes a compound, it becomes fluoride. K is potassium. And H is hydrogen. When it becomes an IDE, we're just chop off the entire second half of the word, hydride. That's it. Try to avoid using hydroxide, because hydroxide is special. It is actually a polyatomic ion. Right. Finally, this guy down here, Na is sodium, and this is a polyatomic ion. That polyatomic ion is sulfate. Right. Now the difference between these and number 3 and number 4 is that 3 and 4 have metals that contain more than 1 charge. So if I look at number 3, look at NiO. Right. Ni, nickel, is right here, and it has more than 1 possible charge. So what I do, personally, when I'm writing the name for this, I write the element, I write the metal, I write nickel, then I leave myself parentheses that I know I'm going to fill in soon, and I finish the rest of the name. Oxygen is one of those funny ones. It's going to turn into oxide. Now, I need to figure out, is the nickel a +2 or is the nickel a +3? Well, hopefully you remember from earlier, that oxygen is always -2. And in order to balance that out, this nickel must be +2. Because the nickel has a charge of +2, that is literally the charge. So the number that I'm going to put in the parentheses down there is the actual charge of the nickel, which in this case is +2. So it's going to be a Roman numeral 2. Give number 4 a shot with that V2O5. See what you can come up with. Again, I will check in with you momentarily. You give it a shot? You try it? I hope you tried it. Hopefully you paused the video. V2O5. So V is right here. It's number 23. It has many possible choices. Its name is vanadium. I've never had anybody correct me. It could be vanadium, but I like vanadium. But it has 4 possible charges, and I don't want you guessing, because you don't have to. Vanadium, some kind of parentheses, O again, oxide, right? I know oxygen is -2, but I have 5 of them this time, so my total negative charge is -10. which means my total positive charge has to be plus 10, right? I have to cancel it out. I have plus 10 charge spread out among 2 vanadium. So plus 10 split 2 ways is a charge of 5. That's a plus 5. So the number that I'm going to write in the parentheses is a 5. All right. Now, this stuff, right, is the last thing that'll show up on the test. What I'd like you to try in order to practice is page 25, this middle section, right? Naming ionic compounds practice, but it's only these ones here. Name the following ionic compounds. It's a combination of the regular ones with no Roman numerals, some of the ones that have Roman numerals, and some of them have polyatomic ions. So do your best, use your best judgment, right? You'll end up submitting this online, so please remember to submit it online. I will see you on, I'm pretty sure D-Day is the next day, and on that day, we will do a bunch of review, alright? However, until then, take care of yourselves. I'll see you soon.